Hello everyone and welcome to the UDAAN podcast. Today we have with us Professor Jayaseelan sir, a distinguished researcher in the field of proteomics and infectious diseases. He is currently the head of Department of Biological Sciences in SRM University, Andhra Pradesh, and is also serving as Associate Dean in SEAS. His work uses cutting-edge proteomics techniques to understand the microbial infections and antimicrobial resistance. Professor Jayaseelan sir, we are really fortunate and happy to have you with us. So, with this, we would be starting this particular session, and I know you personally, but students would like to know about your journey. So, could you briefly share your academic and professional journey from your PhD days in Germany, your time at Freie University in Berlin, and what brought you back to India?
Yeah, thank you, Neelap, for this session. In principle, I will start from my MSc. I did my MSc Biochemistry from University of Madras. Then I have another MSc in Applied Nutrition from National Institute of Nutrition, ICMR, Hyderabad. Then after several years of teaching in India, I moved to Germany for my PhD, where I did my PhD at Helmholtz Center for Environmental Research. And I'm very happy to tell that we are the first batch of proteomics students. So PhD in proteomics was started with us in 2006. Then I was doing PhD, and in the 2 years and 6 months, I got an opportunity to become a group leader at Free University Berlin. So I have to wind up my PhD work, and I completed my work, and then I moved to Berlin as a group leader. There I started the group of proteomics within the institute called as Institute of Animal Hygiene and Environmental Health. So you might be wondering, it's a completely different set of laboratory. And we work with several things, with several animals and several infectious diseases. One of them was microalgae. This microalgae is very peculiar. You cannot distinguish this because it resembles the fungi and in the microscope, and it grows slowly, and there was no easy method. You need to go for 2 PCR steps that will take days or weeks. So what we did is that we put mass spectrometry, that means proteomic based identification. That was in way back in 2012, and we were successful in identifying that and announcing to the world, yes, this can be easily done. And after that, we did a lot of proteomics work, and I was also teaching there for the PhD students. So I was a part of Dalam Research School of Biomedical Research. We call us DRS. And in 2018, I got an opportunity to come back to India at SRM University, Andhra Pradesh. It's a newly established university of SRM group. It was established in 2017. They were looking for really internationally trained faculty members. So I took this opportunity to come back. We started the Department of Biological Sciences, and where we started BSc in Integrative Biology. This is a course where we integrate biochemistry, microbiology, biotechnology, plant sciences, animal sciences, everything together. And that was highly successful. I'll tell later about all the success we made. And in 2023, after COVID, we started MSc Molecular Biology and Biotechnology. This also a unique course. And when I started my career here in India, I want to establish a department which has got the faculty colleagues who has got training within QS rank 10. But you know what happened? We got QS rank 5. So we have colleagues from University of Cambridge, University of Oxford, Boston College. We have people from trained at Jerusalem. We have people trained at Canada, USA, and at the moment we have 14 faculty members, and all are trained at premier institutes, and we are doing really good job.
Yes, sir, definitely. I have seen the faculty list, and to let the students know, I also have worked under Jayaseelan sir for some time in SRM University.
So yes, I want to highlight this. Dr. Neela also helped us in teaching our undergraduate students in the early days, and that was amazing job. Of course, he was teaching from remote, but we did a good job. That was early days, I think 5 years before, or 4 years before. Yeah, that was a good job.
Yes, sir. and the faculty members in SRMAP are really, really nice, and really they are really trained very well in their respective fields. So now coming to the next question, sir. I mean, I definitely know that the area of proteomics and antimicrobial resistance are hot fields in life sciences. So what made you, or what inspired you to get into this area? Now people are nowadays interested in cancer biology or neurobiology. So what was the story behind that?
I went to Helmholtz Center for Environmental Research in Leipzig. As I mentioned, we started with the Department of Proteomics. So I got trained in proteomics. So I got first-hand training from different faculty members and even directly from the company. So I got to know about the gel-based proteomics approach and mass spectrometry proteomic approach. So before coming to India, I'm well trained. When I entered in India, I want to start my own research area. So I was looking, one of the factor that is always getting into mind is that environment. In Indian environment, we have issues with the antibiotics, issues with the fertilizers, issues with the disinfectant, and issues with all pesticides. So you have to listen. Antibiotics, fertilizers, pesticides, disinfectants. So this one, we use it left and right. And what happens is that because of this, the microorganisms acquire resistance to all of this. And sometimes if they get a resistance to pesticide, it's also cross resistance to an antibiotics. So as a consequence, at one point, we will reach a position where the antimicrobial resistance will be prevalent, and we cannot treat even a common infection with an available antibiotics in the market. So this is high time for us to wake up, to look what exactly contributes to this antimicrobial resistance, how to control them. So with my proteomic experiment or experience, I started the antimicrobial resistance to show two things. One is that to understand how this antimicrobial resistance spread in the environment. The second thing, if there's a disease outbreak, how to detect them, identify them in a faster phase. This is very important. The COVID also has given a lesson to us. When there is an epidemic or endemic, we need to really fast in identifying them so that the treatment can be done. So, and in summary, the environment we want to work out. So we sort of doing antimicrobial resistance, and then proteomics is my area of expertise. So I combine both the things, and it becomes really a very good field. At the moment, nearly 8 PhD students are working under my group. They're really doing very good job.
That's really nice, sir. So talking about the international reputed institutes that you worked in different institutes of Germany, and now you're working in India. So how do you differentiate between the research culture in India and in Germany? So what is the basic difference between the research culture?
Yeah, there is a lot of difference. The first difference is understanding the concept. Here in India, what we do is that we have a lot of theoretical knowledge. When it comes for the practical knowledge, we have least experience. This is one problem. This is one challenge. I would say it's not a problem, it's a challenge. So we have good idea, but the practical experience is less. So we want to work a lot. For example, if I ask a student, what do you want to work? They will tell, oh, I have a potential drug molecule from a plant source. I want to use this in the treatment. That's not easy. You have several steps. So this is what we need to learn in India. Otherwise, we are also doing good job. In Germany, the work culture is completely different. They take a smallest concept and they go deeper and deeper, and they have a perfect understanding over the basis. So that's what we are doing. Here we learn a lot, but the practical experience is very less. That's what exactly we are doing in SRM. We started introducing the research culture. For example, 2 weeks before our first year started, yesterday, I went to my individual laboratory. We have individual laboratories besides master's and bachelor's laboratories. 3 of the first year MSc students were standing in the laboratory and talking to the PhD students. Oh, what are the research you are doing? The curiosity starts there. I hope this culture will spread across India and will fill the gap between the knowledge and the practical aspects.
Okay. Sorry, as per my understanding, in India, at the BSc level or MSc level, we do not have that much of research experience, and directly research exposure comes in PhD. So, in Germany, is it like that? For the students from their bachelor's or master's level, they start getting the research exposure?
In Germany, earlier days, they had what we call as diploma Arbeit. Diploma is a master level degree. It's a 5-year degree. It's like equivalent to our BSc and MSc. Arbeit means it's a work. So they submit a thesis and they literally work in a laboratory and they have a perfect understanding over that. This one is very, very clear with that. And moreover, their laboratory chemicals availability and the instrumentation, everything is in advanced stage. But here, we emphasize on learning first, and our laboratories need to update it. Nowadays, it's getting updated. Most of the laboratories are getting updated, but we need to update ourselves. So this gap between what we learn and what we practice has to be filled. So this is one. So this is the main difference. And second thing, that the students used to learn something stress-free. Here we are in a race because we have a huge competition. For one application or one position, we have 100 applications. So we are taught to go for a race. So this race has to be stopped. We need to go for our knowledge. There's a lot of things we can do. You need not be a scientist. You need not be a professor. You need not be a guy who is working in a company. You can be a science training outside the academia. You can be a policymaker. You can be a scientific author or editors. I can quote someone. For example, I can tell Nature India editor, Dr. Subra Priyadarshini. If you look at her profile, she comes from a science background, then goes into journalism and doing perfectly well. So we have a lot of examples in India. I think this will come up in future.
Okay, I understood this. So, since you are working in the area of antimicrobial resistance and infectious diseases, so this is a very hot topic in life science as of now. So, could you guide students that what skill sets should the students develop if they want to enter this field? Because at the level of bachelor's and master's only, you should be starting to develop these skill set only. Then you would be able to survive in the cutthroat competition of PhD if you want to do it abroad or if you want to do it in top-notch institutes from India.
Yes, this is a very, very good question. The simplest answer is that you need to handle the experiments in simple way. You need to know where to start, and how to record the experiments. So this particular recording the experiment is not taught to us. We miss to record. We just write the essays and other things, but we miss to record the observation. When you write the observation in a 360 degrees, you will come to understand what is what. For example, if you know about a bacteria, first thing you need to know how to handle it. Your safety, laboratory safety, and the bacterial safety itself. You should not be contaminated in the lab. So all the safetiness you need to follow. And once you learn this safetiness, how to handle everything, then you can literally think of hitting anything at higher level. So there should be one scientific question you should find, a scientific gap. What I'm going to do in the laboratory? Am I going to culture it? I'm going to culture and check it what I'm going to do. And am I going to culture and test and further interpret it? So this is what we need to do. So this kind of things we need to do. When you combine several aspects together, several skill sets, say your understanding, your calculating how to do an experiment, what we call as planning, how to execute your experiment. After planning, you need to execute, and to how to document the experiment. Documentation is very important. How to document, and then how to analyze them, how to understand them. For example, if I write the number 6 between you and me, what you will read? You will read as 9. I will read as 6. So how to distinguish this? Which one is right? So this is what we need to understand. So when nowadays the youngsters are doing this good job. I find at least in my university, because of our laboratory proximity, I'm able to see that they come with a good questions.
Mhm. So, sir, what according to you, what would you suggest to the UG or PG students how they can learn the things you just said? That means recording and understanding what they are doing, understanding what they have to do. So, what are the steps or what programs that they should join before doing before coming into a PhD? How should UG or PG students approach this, or where can they learn everything?
They don't need to go anywhere. They have to stick with one of the book textbook, maybe a biochemistry book and a microbiology book if they want to come in life sciences, or even in plant sciences, or even in animal sciences. There are a lot of questions to be answered in even animal sciences and plant sciences, and a lot of questions within biochemistry and microbiology. So when you understand the basic concept, when you have to keep a track on what you're reading and what you do, that it is not a big thing. Make it simple. Make it simple, understand, and then automatically you will find out a gap, knowledge gap. So this will be organic gap. We are not feeding them. We are not training the technicians. We are training the scientists. One important word is that I underline the word. We are not training the technicians. We are training the scientists. So the scientists should come up with an organic way. They have to find out a good answer for things. There's no boundaries. Anyone can come. Even a physics guy can come into biology, and he can do wonders. I can quote an example also. I have seen my own classmate. He was a physics guy. He did PhD in biology. He did extremely well.
Mhm.
That's possible. So only thing is that our understanding, take time, learn, listen carefully, and what is the society need now? The societal impact factor. It's not the impact of any journal. It's not the impact of patenting. It's not the impact of publishing. It's the impact what it can cause to the society. When you are thinking in this term, naturally we can find out, or any student can find out his own strength and his own area of research.
You correctly said that, sir. We are not training technicians, we are training scientists. Very right. So now coming to SRM University, Andhra Pradesh. So I personally know about the university. The university is doing fantastic, but students would also like to know about the university. Many UG students and many master students and many potential PhD candidates, since CSIR results have recently been announced. So many students would be looking for opportunities like PhD, MSc, or UG. So, being Associate Dean of SEAS and being the HOD of Biological Sciences, can you highlight the unique opportunities SRMAP offers, like research internships or PhD programs or international collaborations, placements, and
Okay.
things like that?
Okay. First, I will start about this university itself. The university was started in 2017 with an objective to make as a research intensive university. That means majority of the staffs, they have their own individual research laboratories, in addition to the undergraduate and postgraduate research laboratory, teaching laboratories. So we have undergraduate and postgraduate teaching laboratories plus individual faculty research laboratories. Besides this, there are common facilities also. So coming to the PhD program, we started offering PhD from 2018 onwards, and this particular program is completely funded by the university. For example, any student who cleared our entrance examination and the interview process will get a stipend on par to the national level. That means 36,000 per month for first 2 years as a junior research fellow. And in first 2 years, if he is able to complete the coursework and publish 2 papers, the student will be promoted to senior research fellow. Otherwise, the stipend will be the same. If it's promoted to senior research fellow, that means third year and fourth year, the student will get 41,000 rupees per month. At the moment, we have 530 students receiving the funding. This is the number. And across 24 departments. Okay, I'll come back to the department later. So the PhD student, besides this stipend, they will get professional development allowance. Okay. This professional development grant, this for the students. Okay, professional development grant. What happens with this grant is that the student can get 20,000 to 30,000 rupees per year at his disposal, where he can go for a conference or become a member in a society, or he can also do whatever professionally he can do. It's free. The student can do. So one is he get a stipend. The student gets a stipend, but monthly stipend. Then annual allowance for doing such kind of activity. These are the PhD students things. Okay. You might ask the question, what if a student comes with CSA or JRF? They will get, in addition to this, there is a presidential fellowship. They will get a little more extra money and extra benefits. This is for sure. Okay. This for PhD. And when you talk about the departments, we have nearly 23 departments, 3 schools. First is School of Engineering and Sciences. That's where I am associated. I'm the Associate Dean of the School of Engineering and Sciences. We call shortly as SEAS, SEAS. Here we have 10 departments, 5 in engineering side and 5 in basic science side: physics, chemistry, biology, mathematics, and environmental science. And we have School of Business. We call it a Paris School of Business, PSB. There we offer BBA, MBA, and PhD program. Besides this, we have Eastbury School of Liberal Arts. We have history, political science, journalism, mass communication. Like that, we have 7 other departments. So they are also offering BA degree, MA degree, and PhD degree. So this is our setup at the moment. The university is ever expanding. You can refer the website for new courses. We have a lot of undergraduate courses, and our highlight is that PhD program. And besides this PhD, we also offer postdoctoral fellowship, and again on par to the governmental fellowship. So again, there will be an interview for the PhD holders from other universities, and if they pass the interview, we offer them 2-year postdoctoral fellowship so that they can build their career. Okay.
Sir, yeah, I would personally like to know about the research internships. Are there any internships that SRMAP offers?
Yes, good that you ask us. Okay. We offer research internship. Any student who wishes to do an internship in any of our laboratories, they can directly write to our professors, our colleagues. They will completely respond you or respond the students, and if they are exceptionally good, the student will also get a stipend, 15,000 per month. That's possible. But otherwise, we are not charging anything. The student can come for summer intern, number 1. Number 2, they can come for their semester project. For example, 1 semester full project they can do here. The advantage of summer intern and semester project is that the student will learn what our PhD students are doing, and they can literally pass the entrance exam and they can continue their PhD program here. That's possible. That's also possible. Or most of our interns, they are flying abroad because this training is enough for them to fly away.
Yes, correct. Sir, about the PhD program, sir, is there only a written examination, or after written, the interview is also there?
Yeah, there are 2 types of entry. First entry is that those who are NET qualified or JRF qualified, there's no entrance examination. They will directly go for a discussion meeting with the professors. They can directly apply to a professor. They can directly go to the discussion meeting. And after this meeting, the professor and the student will agree, and they will write the application to the university. They will be selected. This is the first level entry. The second level entry is that those who are having master's degree, they will write an entrance examination and followed by an interview. And this interview will be conducted by the particular department or concerned department. Good thing is that you need to submit your application after your entrance exam. If you qualify for the interview round, the university will reimburse the travel convenience. For the interview, the people can come here, stay, and look what happens this. And once they selected, either direct entry through CSA or JRF or NET, or DBT or ICMR or ICR NET, or even GATE, direct entry. The second one is that through entrance plus interview, the student will come, they'll be given 1 month time to go across the department, all the faculties, all the labs, to choose their laboratory. This one advantage. They can choose it. 1 month is there.
So even GATE
And
is admissible, sir, for PhD?
yes, valid score, gate score, we exempt the candidate from appearing in the entrance examination.
Okay. Sir, many students ask about the industry exposure and placement opportunities in the private sector. So can you tell more about that in SRM?
Okay, good thing is that we have a separate supporting department for the industrial placement and training division. Uh, they do a good job and they collaborate with our faculty members. Each master's program or bachelor program, they have a course coordinator. This course coordinator will coordinate very closely, and we will ask for the interest of the candidates, and we are connecting the candidates or the students to the industry. So in the first batch, for example, of MSc Molecular Biology and Biotechnology, all 20 students, they went outside to the industries. That was one. So that is a supporting team. Plus, besides, our faculty colleagues will also support. So this is there. As far as the placement is concerned, we are completely new. It's only 3 years have done. We have done some placement, but we are working. I think in this year will be completely placed for sciences. For engineering side, 100% placement. There's no second thought on it. And business administration, everything they're doing good job.
Okay. Sir, could you share any success story of a student who might be working under you or your department who got benefited with the research internship or training under your department?
I can tell a lot of students success story. The first 3 batches what they are doing. I can take one student, Gautam. I can tell the name also. This guy is from Andhra Pradesh. He came to us for BSc in integrative biology, and he literally wanted to do an evolutionary biology. This is very unusual, right? So a bachelor student want to do evolutionary biology, and he ended up in University of Kiel in Germany doing his masters in evolutionary biology. This is one. Number two, in the Department of Physics, there was some students, I think 2 students, they went to Erasmus Mundus fellowship. They went for Erasmus Mundus. That was really successful. And yeah, we have stories like this. And one student, our BA history student, she got MS in computer science in US. Unusual careers. So we have a lot of stories. I just, for time being, I mentioned whatever it comes. And one more I want to highlight. One of our ECE student, ECE student, BTech ECE student, she cleared 5 government examinations. ISRO, Port Trust of India, DRDO, and 2 more. This happened last year. If you go to our website or in the Andhra Pradesh news channels, it was a news in the Andhra Pradesh itself. That was one success.
Okay. Okay, sir. Fabulous. So now, sir, I would want to come to the area where most students would be interested in about the guidance section. So many students, as you would know, from India dream of going abroad, studying abroad, working abroad. Now, since you had long experience and exposure in German institutes and in Germany, what should the students have in mind before applying to opportunities abroad?
Oh, that's a wonderful question. If you're applying for a structured program, you need to prepare yourself to face their admissions, other things. If you're applying to a professor or to a project, you need to be brief and you need to be to the point. You cannot claim yourself, I'm a hardworking, I am sincere, dedicated. All these words are not going to help you because everyone writes this. And no chat GPT words also. You have to be genuine. You have to read their literature, what they have done, and you need to be connect to them. First, a connection. So you need to connect to their science, what they're doing, and you have to tell, yes, I'm interested in this particular field because of so and so reasons, and very short. And then you have to tell them, okay, I will work on this particular aspect, and I wish to become a PhD student or a master student. This will literally help because 2 things you got to understand. The leading university professors receive hundreds of such email. how your email is attracting the professor. The professor will have maximum 15 seconds to read your email. So no lengthy statements. Very clear, to the point, and a precise, simpler statement. No high vocabulary. People used to go for very high vocabulary. What do you want to show? Your language skill or your scientific interest? Here you are very clear, you need to show only your scientific interest. So language skill is important, but here the primary requirement is your scientific skill. So you have to take time to design such a letter or such email, and your CV should be also precise and to the point. For example, if you're going to a particular country, check what is the format they work for. That's very important. You cannot stick with your own format. All the colorful and everything cannot be working. So this has to be taken into account. So in summary, you have to be precise. You need to the point, and no extra words like I'm working hard, sincere things. Who is going to write I'm not going to work hard, I'm not going to be sincere, I'm going to spoil? No. So everybody writes that. So you have to define yourself. You want to tell what is your goal, what you want to achieve, and why you want a position there. That's very important. The justification. Then your CV should be in the position to impress it.
Sir, one very important question that I often get from students is, suppose someone has studied, let us say, neurobiology in bachelor's or master's, and suddenly he is not interested in neurobiology and wants to work in a different field, let us say ecology or something like that. So, would a professor from Germany, or let us say from you only, if someone wants to apply to you, he or she has a different background altogether, does the professor address to emails like that, having a different background and applying to a new place?
Naturally, they will address, but you need to, as I mentioned, you need to impress and to the point, and you need to, what new idea you're going to bring.
Okay.
You cannot tell that I want to change my field. That's not the reason. Okay, change your field, but you need to tell them why I want to change the field, what I'm looking there. So if you're writing this one strong, then the professor will address. As I mentioned, professor will get hundreds of email like this. So most of the time, they will not be in the position to answer because they don't have time. They have to understand the fact. They don't have the time. And if they are answering, please thank them. Please thank them. This is one such things we need to learn. So the interdisciplinary research is most welcome. And they literally look for such kind of people. So, for example, if you're a biologist or a biochemist and you know a computer and you want to go into ecosystem or ecology, then you're most welcome. You know this all three skills where you're going to bring a new development. So yes, it's advisable also.
Okay. So one more quick question. Students from India do not focus upon the recommendation letters. So could you highlight upon that? What role does a recommendation letter play when a professor from outside is reading the application form of a student?
Yes, first thing is that once the professor is impressed by your CV and your interview or your own application, then the recommendation comes into play. In the recommendation, it should be very crystal clear what's the relation between the professor who is recommending and the student. He cannot meet in one conference. That will not help you unless it is impressed. If it can be working, but it's really impressed. So it has to state, I know this candidate from so and so time in so and so position where I also taught him in so and so course. Then you connect to the candidate to that particular topic. It's very specific. So you can write here, the professor can write hardworking, sincere, dedicated, and the student has worked on so and so project in my laboratory, which is related to this project. And this process would also justify, yes, I strongly recommend this candidate. Otherwise, I could also accommodate this candidate in my own lab. So this makes little one step for the things. So in essence, the process would also connect the candidate or this ask his student to their future project. So that will help us.
Okay, sir. So the next question is, sir, for students who want to build a career, strong research career, what advice would you give about balancing academics, research skills, and networking?
Yes, there are 3 or 4 aspects. Huh? The first aspect is that your basic idea about the research. The second aspect, where to apply this basic idea. You will be having a lot of idea. You don't know where to go. So you need to find the right mentor, right laboratory. So you might be having a big idea. So you need to have a right mentor and right laboratory. So it should support you. If this 3 is there, then you start building what you want to achieve. So you want to become a scientist or a teacher or an entrepreneur, you decide and proceed towards that. There's an instrument called biolog. The biolog is an instrument that's used for bacterial phenotyping. In principle, it has 96 well plates and it can measure all the 96 well plate continuously for 72 hours or for the inventor of this or the company owner. He got this idea during his PhD and he implemented that, and this instrument is very expensive and it helps a lot. So the students should also chase such kind of dreams.
Yes, understood that, sir.
So they
So,
have to have an organic idea.
yes, correct, sir. So, for students who, I mean, many of the students would be watching this podcast and would be aiming now to make a career in proteomics and antimicrobial research. So, can you tell, sir, with your experience, where do you see this field in the coming 5 to 10 years?
Oh, in the future, I tell you, you walk to the hospital and you have some infection and you need to know what is the infection, what kind of resistance it has. Otherwise, the treatment is very difficult. We cannot keep on testing the patient. So the fast diagnostics, we call it the rapid diagnostics. The rapid diagnostics of the microorganism, antimicrobial resistance, this will play a big role. And once this diagnostic is done, then the patient start receiving the drug. Then the prognosis, how this is, maybe we should have some markers and other things where this treatment is going in the right direction or it's not working, because whatever that works for me may not be working for you.
Yes.
So this is one thing. This is the first thing, the hospital associated rapid diagnostics and prognosis. Number 2, the community based things. If there's an outbreak, so we need to really address it very fast and we need to forecast. Okay, there is a likely to be raining in so and so region and this particular bacteria may hit that area. We have to accurate prediction. So epidemiology, community level things will also work at that. And third thing, going with your what you call as the microbes in the food. So we come across a lot of food. India is known for food culture also. We have a food diversity and the pathogens vary from region to region. And again, this also going to play a role. So if you know about the microbes and the antimicrobial resistance, we can literally avoid this, the food and associated industries. So these 3. And then 4th one is how to engineer or use this microorganisms with resistance and other things to use it for useful purpose, beneficial purpose. They are dangerous. Okay, can we explore them for using it for an industrial purpose, say producing a new substances which can inhibit the growth of another bacteria or a fungi or some other microorganisms. So this is also going to play a big role in future. How this industrial revolution will also happen. And there's one more thing. We are going to eat a lot of bacteria in future, what we call as probiotic and prebiotic. So the probiotic and prebiotic, which kind of combination of this things we have to take? For example, I can give a good example for a future generation. You have curd, the curd, yogurt, curd, buttermilk, everything. People started adding probiotic in the in them, and they started giving. What is the proof that the probiotic is active? There's no proof. So the company requires such kind of testings. So this kind of new things also will appear. The food-based things, food and feed, the animal feeds also. For example, in the poultry, long back, we were using tons and tons of antibiotics. Now, slowly we started using the plant-based material that gives the resistance to the disease. So we are stopping at the before it occurs. So that's a good change. The chicken which you are getting will be organic in nature. I mean, of course, it will take for the different kinds of food, but it will not be carrying any pathogenic bacteria. It will be resistant to the things. So this is what the future is about. So we need to open our eyes and look in all the aspects.
Okay, correct, sir. So many students are confused about what options should they take for their PhD. I mean, in which areas of life science is the PhD a good thing to do? Because they are confused about whether they should go in academia or they should go in industry. Can you suggest some areas which might be useful in academia as well as in industry?
Yeah, this question is very interesting question. What should I do? That's the real question. So I would say two things: do everything or do nothing. I tell you why do nothing and do everything. The moment you start your PhD, you should also know what you are going to achieve at the end. And when you're working the PhD, you will have a lot of new ideas. During that time, you should also think of your own product or your own contribution to the field. So if your happiness comes with teaching the science to the next generation, go with the academics. If your happiness comes with achieving something, earning a lot of money, you go to the industry. And as such in India, the industrial levels are going up. It has to be enhanced because the government is also trying to do that. I can tell you one Indian, very famous one, he went to receive a Bachelor of Technology in ECE, Electronics and Communication Engineering. Then he went to Germany for diploma in computer science. You know what he's doing? He's running the number one company called Sanda Biotech. You can see that
Entirely
science,
different fields.
yeah, science, and you can see completely different. He brought revolution in the vaccines. He brought revolution. So what I tell you is that the young generation, be like a honeybee. People can take the honey from you, not the art of making honey. Generate more and more ideas, and you test all the ideas. No one knows one sure successful formula. So test 4 or 5 ideas, and one idea will click. So be like a honeybee. You have the idea of how to make a honey, not stick with one honey. Oh, I have made the honey, no one can steal it.
Yes.
In India, we are very proud. We have completely eradicated polio.
Mm.
Every one of us received polio vaccine free of cost. How was it possible? When Salk in 1954, when he introduced this vaccines to the community, there was a news reporter was asking, who owns this patent?
Mm.
The Salk answer is epic. He told, I think it is people. And he laughed and he asked, who could patent the sun? Who could patent the sun? So younger generations should be like honeybee, generate ideas and start throwing these good ideas everywhere. And 1 or 2 places, the idea will start growing. Whenever there's a good soil, it will grow. Even if your idea is good, even on the rock, it will grow.
Wow, what good words, sir. Now, coming to the closing portion of this podcast, what message would you like to give young students who aspire to build careers in research and higher education? You already said that, I understand, but what would be a one-liner message that you would want to give to students?
Be focused and consistent and
Yes.
never give up. and
Yes, sir.
prepare to face the failures.
Correct.
Very
Very
important.
nice.
Very important. You generate 10 ideas, 9 ideas may go failure.
Mhm.
So no worries. You still think that there's an idea left for you. There are always a door waiting for you to be opened. So
Okay.
you be alert, find out the door, and knock the right place, open the door.
Last question is, sir, if a student after listening to this podcast want to communicate with you or to any other faculty member of SRMAP in biological sciences, what is the best way to go forward?
Or they can write an email to me, number one, or they can contact any of my faculty members, or if they want to visit us, they're most welcome. Any part of student from any part of India, they're most welcome. They can contact us. They can come to our lab, spend the time. They, for example, they want to spend one full day. Most welcome. 10 students from, say, from Lucknow wants to come here.
Hmm.
We'll pick them from the railway station.
Sure, sir.
We'll tell
Definitely.
the science. We are here to talk the science. We don't
That
mind.
is, yeah,
We
that is
don't
really
mind.
nice, sir.
Keep on talking science. I told, be like a honeybee.
Yes.
Spread your ideas and let anyone get the things. And we are, remember, we are building nation India.
Correct, sir. Thank you so much, sir, for sparing so much of time and talking to us for the benefit of the students. And really, SRMAP is doing a fabulous job for training young researchers, and you are doing a fabulous job leading the biological sciences department. Thank you so much, and have a good
Okay.
day, sir.
Yeah. Thank you, Neelap. Thank you for this opportunity to express our views. And we have a lot of things to talk. If the student comes, we are ready to talk to them. Okay. We'll catch up sometime.
Yes.